In this lesson, we'll be going through the converse of the theorem 1. So basically, what is a converse? Well, I can explain it this way. Suppose I say to you, in order for a person to be a human, they must have two eyes, right? It's a theorem. It's a statement, right? Listen to it clearly. In order for a person to be a human, they must have two eyes. Wow, what is a reverse of that? What is a converse? Well, it means that if a person has got two eyes, therefore it is a human, right? It's more like a theorem, it's a forward version, and a converse is a reverse version of it. If I say, in order for something, for an object to be a pen, it must be orange. It's an example, right? This means that if an object is orange, therefore it's a pen. Like this is what you must know between the theorem and a converse. I'm sorry. So, a theorem and a converse are simply brothers, okay? But the one is the reverse of the other. So, because the theorem says a line from center perpendicular to the chord bisect the chord. Now, what will the converse say? Okay, let's write the theorem here. The theorem 1. The theorem 1, right? Theorem 1. So, theorem 1 says line from center perpendicular to the chord bisect the chord. It bisects the chord. So now let's write this thing in reverse. Well, if a line bisects the chord, therefore it is perpendicular to the chord. Do you see it? If a line from center bisects the chord, it means that the line is perpendicular to the chord. But the theorem says a line from center perpendicular to the chord bisects the chord. It's like we're writing the statement in reverse. So the one written in red up there is the converse, and the one in blue is the theorem. So make sure you're able to grasp the difference. That the other one, I'm sorry, the other one says that if a line from center is perpendicular, therefore it bisects. But the other one says if it bisects, therefore it is perpendicular. This is basically what it means here. So make sure you're able to tell the difference between the converse and a theorem. Okay, so the reason we give when we're talking about the theorem, suppose they are given, okay, let's have an example. Suppose they give you a circle, and then they give you, okay, we'll just assume that this thing is perpendicular. Okay, so we know that if the letters here, for example, let's say here is perpendicular, here we've got A, we've got B, we've got C, and we've got D. So if AC is a theorem, right? Let me write there what is a theorem, so that you guys don't confuse things. So it's a theorem. Theorem 1 says that if AC is perpendicular to BD, therefore BC is equal to DC. Now, what reason will you give there? Well, just say a line from center, then write perpendicular to the chord. It's a correct abbreviation. It's a correct shortened version of it, and you will get a mark, right? So it's a theorem. It says that if a line from center is perpendicular to a chord, therefore it bisects the chord. Okay? So just say line from center perpendicular to the chord. So now let's say you are writing the reverse now. What will the converse say? Let's see. Feel free to pause the video and try it. So the converse will say that, let's write the converse. Converse will say that if BC, okay, this is if, it's a if statement. If BC is equal to DC, therefore AC is perpendicular to BD. Right? So this one will say a line from center to midpoint of chord. So it's midpoint of chord. So this is the difference between the two. A theorem says a line from center perpendicular to the chord, right? That's what? Bisect. Therefore, a converse says a line from center to midpoint of chord. So if AC passes through the midpoint of a chord, therefore it is perpendicular to that chord. So make sure you are able to do these things, okay? So a theorem, the statement that can be backed up by a proof, and a converse is the reverse of a theorem. So make sure you understand, and feel free to ask in the comment section if you need clarification on a lesson. Thank you for watching.